So, you are curious how Unity's new input system works. Maybe you are new to Unity, or you are just ready to switch over to the new input system. In that case, you are at the right place. I am Code, and let's jump right in. The new input system is a little bit more complex and has a bit of learning curve, especially because it works different than the old input system. The old input system forced us to evaluate the input in the update function. The new input system produces a much cleaner code by using events, and the new input actions helps to separate physical actions from the logical input in a nice new editor. First, make sure the new input system is imported in your project. Create input actions in your desired folder by right-clicking in it, select Create, and then Input Actions. It will create a new input action for you. I will rename it to My Input Actions. If I double-click it, it will open the input action editor, and I will dock it here in the middle. I create a new action map called Player. Action maps are collections of input actions. You can have separate action maps for the player, the menus, or when the player get mounted or enter a vehicle. In the middle, you will find the actions. On the right, you find the properties of the selected action. Unity auto-created for us a new action. Let's rename this to Move, and also add Jump, Run, and Look. Actions needs bindings to set up relation to the physical inputs. If you click on the little arrow, you can see Unity already created empty bindings for each action. Select the jump actions binding. We start with the jump because that's the most straightforward to set up. In the properties, under binding, click the path drop-down, select keyboard by location of key, and search for space. Now we have assigned space to the jump action. Let's click the plus on the right of the jump action and select Add Binding. While the new binding selected under Properties Binding, click the path drop-down again, navigate back up, select the gamepad, and look for the button South. Now we have two different bindings for the jump action. Next to set up is Run. Let's assign the left shoulder button from the gamepad and the shift from the keyboard. You can use the search. What we learned so far, you could use for movement and set up 4 different buttons for up, down, left and right, but there is a better way. Move action currently set to be a button. So when I click the plus icon, I get 4 options. Add bindings for a simple key down, 1D axis composite for scrolling or throttle type action, and 2 more options to handle multiple key combos. None of these are what we need. So let's change the action type to value and control type to vector 2. Now when I click the plus icon of the move action, I get a new option, add 2D vector composite. I will select that. We got a new 2D vector binding with up and down, left and right options. Let's attach a keyboard button for each. We can click listen in the path drop-down and hit the right key to find them quickly on the keyboard. Click the empty binding and use the path drop-down to browse or search for the gamepad's left stick and select it. The stick's up, down, left, right directions will be automatically mapped by Unity. Next is the look action. I will set the action type to value and the control type to vector2, same as for the move action. Click the empty binding and in the path drop-down, search for delta pointer to capture the mouse movement changes. Click the plus icon on the look action to add one more binding and assign the right stick from the gamepad. Let's click Save Asset to finalize our changes. As I keep forgetting to click that button, best to tick the autosave on the top right, so any further changes will be automatically saved. Find your input action file in the project browser, click it, in the inspector tick Generate C# class and hit Apply. You will see a new script file generated from our settings. We need this file to access the input actions. The input actions are ready, so let's use them. I have set up a simple scene with a camera and light and a level for our player. The camera is the child of the player, positioned slightly behind and above the player. This is a very simple setup just to demonstrate the input system in action. The player has a capsule mesh and a collider, and I place the little cube to show where is it facing. Let's add a new script to the player controller, and double click to open it. On the top of the script, add using Unity Engine input system. In the class, add my input actions or whatever you name the C# file generated in the previous steps. Add the two vector2 attributes called move and rotate, a float for jump started, walk speed and run speed, and the last two are optional for this example. Camera called player camera and the vector3 camera rotation to track the camera rotation. I save and let me assign the camera to the player camera right away before I forget it. We need to enable and disable the input actions when the player is enabled or disabled accordingly. I will add two private methods, onEnable and onDisable. We'll add input action player enable into the onEnable method where the player refers to our action map, and add input actions player disable in the onDisable method. I will register all the needed action callbacks into the awake method. I create a new input actions where the input actions player is our action map, and then jump, run, move, look are the actions. Each of these actions in the input system has performed, cancelled and started callbacks. For this example, performed and cancelled will be enough. CTX is the callback context, and right of it we find our function call, which can be a method or a simple statement. For example, I set up the run attribute by walk or run speed depending on the run action state. At move and look, I need to use the read value on the callback context to access the vector2 value. This will update anytime the player interacts with the mouse, the keyboard, or the controller. I need to detail the jump method. I do a rudimentary implementation for all movement, as the goal of this tutorial is to show how to use input actions, not create a fine movement controller. Typically I would trigger animation here, but that's out of scope. So I will add the simple timer to record when the jump was initiated. Jump will take 1 second in this example, so I need to ignore any other clicks while the jump is performed. On the start method, I just set up some starter values like walking speed, the initial camera rotation, set the jump starter to -1 and log the cursor. Last is the update method. This is only a very simple example just to demonstrate how to use the rotation and the move values updated by the input system. First, I calculate the camera rotation as the mouse or the controller x-axis is vertical and the y-axis are horizontal. However, 3D space is a z forward space. So I have to map rotate y to camera rotation x and rotate x to camera rotation y. Then I will update the camera, the player camera, with the new values, and I rotate the player the same way horizontally where the camera faces with the calculated camera rotation. Then I update the player x and z movement using the right and forward vectors, and I multiply with the move attribute x and y values and the run speed and delta time. Lastly, I just move the player up for half a second and then down for another half second if the timer on the jumper was set. There are better ways to do this naturally, but this will do for the demo. If I save and we run it now, we will see the controls are too quick and also some of them inverted. Let's fine-tune some of the settings in the input action editor. Click look action and select the mouse delta binding. You may already notice under properties there are two more sections: interactions and processors. Interactions represent different input buttons like tap, multi-tap, hold. Processors take a value and return the processed value of it. I will select invert vector 2 and I will invert the y-axis only, and I also select scale vector 2 and I will set both x and y to 0, 0, 3 to slow it down a bit. On the look action, right stick binding, I will also add the invert vector 2 and the scale vector 2 and the stick dead zone processor. I invert only the y-axis, set the scale for both x and y to 0.3 at this time, and I leave the stick dead zone on default. On the move action for the left stick, I will add a stick dead zone as well and leave it on default. Let's test it. I can look, move, run, and jump. Perfect. Unity's new input system offers even more. But this should be enough to get you started. For more Unity tutorials, please subscribe. See you next time!